We're now going to look at confidence intervals for means. Before we get into the specifics, I always want to remind you of the purpose of confidence intervals in general. And that is, confidence intervals are created to capture something. And that something is some true value that you're interested in. Now, the first confidence intervals we were talking about in the previous videos, the thing we were interested in capturing was a population proportion, capital P, or P without a hat. So now we're going to be interested in capturing a population mean. And I hope you remember the symbol for population mean is the Greek letter mu. So let's remember the general structure of all confidence intervals. There's always some point estimate, plus or minus a given margin of error. Now, for trying to capture the population proportion, that point estimate was P hat. So, my question to you now, what should we use to estimate the population mean? And I hope you are ahead of me. We should be using the sample mean. Just like P hat was used to estimate the population proportion, X bar is going to be used to estimate the population mean. And of course, what else comes after that is we'll figure out some way to get the margin of error. And that will be our confidence interval. So, quick aside, where do we get this point estimate? Well, for most problems, you're going to run into one of two ways. It will either be given to you, or, so that's one way. The second way is you'll be given a data set, and you'll have to get it yourself using our good friend 1var Stats. And we'll look at an example of both of those. And then the margin of error, again, like with proportions, there's a formula that will help us, that could help us get that. For right now, we're just going to go pure technology. We're going to skip the formula, and we're going to move to our calculator, ask it to give us a confidence interval, and the sequence of buttons will be stat, over to the tests menu, and it will be choice 8. What's called a T interval. All right, so let's look at our first example. Let's say you were interested in the commute time of Butte College students out to campus, and you surveyed 80 students. The average commute time was 25 minutes with a standard deviation of 5 minutes, and we would like to create a 90% confidence interval to capture the true commute time for all students. So here we go. As I said over here, these are the instructions to get to my calculator. So let's get our calculator in front of us and let's do this. So, stat, tests, number 8. You don't have to scroll down, you can just hit the number 8, but I just wanted you to see, there it is. And here at the top, we have the title T interval. It asks, what type of input do you have? Do you have the original data, or do you have the summary statistics? Well, it looks like we don't have the original 80 list of 80 values. It looks like we have the summary stats. So I move down and I tell my calculator the sample mean was 25, the sample standard deviation was 5, the sample size was 80, and we would like a confidence level of 90%. So the inputs are friendly. We hit calculate, and let's see what it gives us. All right, so let me write that down to 2 decimal places. So 24.07, comma, 2593. So let's interpret this in a couple of ways. One is I'd always like you to identify the point estimate, which is the number halfway between these two endpoints, but it's also just x bar. So we know it's 25 plus or minus, and then ask yourself, how far is 25 away from 25.93? And I think you can see it's 0.93 away. You could also check to ask the question, how far is 25 away from 24.07? And it's the same distance. So here's my confidence interval in two different ways. What's just as important is making sure we understand, what does this mean? And here's the one sentence explanation for what this interval is telling me, is that we are 90% confident the population mean for all Butte students is between 24.07 and 25.93 minutes. Boom. All right, let's take a look at our second example. This will be the last one. So here's the setup. It turns out mandarin oranges that come in cans come in 11-ounce cans. And let's say you were noticing that the cans seemed to be a little bit light. You felt like you were getting ripped off. And so it turns out you went ahead and bought 7 random cans of mandarin oranges, dumped out the contents of each, and weighed them. And it turns out for almost all of them, your hunch was right. It looks like they're coming in just shy of 11 ounces. So what we'd like to do is create a confidence interval to capture the average of all cans of mandarin oranges. If I could open up every single one and weigh them, that's what we're trying to capture. So this is what we need to do. On the first example, we were handed the summary statistics. On this one, we have to take an extra step. And you may remember OneVar stat. If it's been a while, we hit the stat button and then we choose edit, and that gets us to our lists. And I've gone ahead and entered those 7 values in list 1. Once you have those, we quit, hit second mode. I can clear out my home screen from the last problem, and we hit stat, calculate OneVar stat, tell it which list, L1, and we've got it. So it's nice to write those down. Let me jot down my 2 summary statistics. My average, 10.705. My standard deviation, 0.38. Let me write down what we know so far. We've got a sample size of 7. We have an average, let's go to 2 decimals, 10.71. And a standard deviation of 0.38. And let's ask for a 99% confidence interval this time. All right. Well, what's nice about this feature is once you've put the data in your calculator and you've run OneVar stat and you're getting ready to get your confidence interval by hitting stat tests number 8, notice what happens. When you run OneVar stat, your calculator assumes you did it for a purpose, and it automatically dumps those values in for you. No need to round off. Let's just take what they give us. Notice it gives me the mean, the standard deviation, the sample size. The only thing that you need to change is the confidence level, which I said, let's go with 99. Calculate, and we're good. Again, 2 decimals will be fine for us. 10.17 to 11.24. So 10.17, comma, 11.24. And again, what that could also look like is I have a point estimate of 10.71 ounces, plus or minus. Now, how far is 10.71 from 11.24? That's my margin of error. It looks like 29 plus 24. How about 0.53? But the question we were really interested in is it possible that the average of all of the cans of mandarins could be less than 11 ounces? And it turns out my confidence interval helps me answer that question. Remember, what's inside here is we're 99% sure that the population average is between 10.17 and 11.24. Is it possible that the population of all the cans could still be 11 ounces? And the answer is yes, because 11 is contained in here. So this sample of 7 cans was not enough to convince me that the averages of the entire population would be under 11 ounces. So my conclusion, 11 ounces could be the population mean since 11 is inside the interval.